Hello everybody, this is a short lecture, a note I should say, related to 1991 IMO problem number 3. Consider the set S of positive integers from 1 all the way to 280, and what I would like to do is to count the numbers in this set S that are divisible by 2, 3, 5 or 7 basically. For that, I would like to define S sub m to be, so let S sub m be the set of integers in S such that these integers are divisible by m, right? Such that integers, let's say k, in S such that m divides k. Okay, so S sub 2 as a result would be the set of all even integers, right? So, and S sub 3 would be the set of all integers in S that are divisible by 3 and so on. So what I would like to compute is, I would like to count the number of elements in S that are divisible by 2, 3, 5 or 7 by using the principle of inclusion and exclusion basically. So that's what I'm interested in counting. The number of elements in this union. Well, okay, so let's first write down the principle of inclusion exclusion plus S sub 2 plus S sub, sorry for that, S sub 2, S sub 3, S sub 5, S sub 7. Then, well, that would overcount, obviously, because some numbers are divisible by both 2 and 3 at the same time. So I need to take those off. So those that are divisible by 2 and 3, and then plus those that are divisible by 2 and 5, and so on. So the 2's. And then I need to add back, we did over subtracted here, I need to add back the combination with 3 of them in it. So S2, S3, S5, plus, as another example, S2, S3, S7, and so on. There should be 2 more here. And finally, subtract the whole intersection, which is S sub 2 intersection S sub 3. Number of integers that are divisible by 2, 3, 5, and 7 at the same time. Okay, so let's do a quick calculation in a side here. So what is S sub 2? How many elements are there in S sub 2? Well, how many even integers in this range? It is simply 280 divided by 2. In fact, just to be more accurate, that's the accurate form to write it. So as a result, this would come out as 140. S sub 3, number of integers divisible by 3 from 1 to 280 turns out to be 280 divided by 3, I think it is 93. S sub 5 would be 280 divided by 5, which is, I believe, 56. And finally, S sub 7, which is 280 divided by 7, and that's also 40. So therefore, the first line, so these numbers are, I calculated these, so they came out as 140 plus 93 plus 56 plus 40 minus, okay, so now the second set. So how many numbers are divisible by 2 and 3 at the same time? So if a number is divisible by 2 and 3 at the same time, we're talking about divisibility by 6. So using this same definition, so S sub 6 would simply be equal to 280 divided by 6, which is, if I'm not mistaken, I think the floor function would be 46. Next one would be S2 and 5, so which is S sub 10. This one is 28, obviously. I don't need to make any calculation here. Then divisible by 2 and 7 at the same time, so that would be S sub 14, I guess. So that one is also easy to calculate, which is just 20. And yeah, so and then we would have S sub, so far we did the 2's. The 3's would be 15, I guess. S sub 15 would be 150, is it 18? I think it should be 18. And then S sub 21, that one would be 13, I guess, right? And finally I would need S35, those elements that are divisible by both 5 and 7, so 280 divided by 35, the floor function, I believe that should give me an 8. So therefore I need to add these numbers to my list, so 6 of these. Okay, so we have 46 plus 28 plus 20 plus 18 plus 13 plus 8. Then we add back the those which are divisible by 3 numbers, namely we can try 2, 3, 5, which is 30. I would need S30, so 280 divided by 30, the floor function I believe should be a 9. I would need 2, 3, 7, 21, 42, I guess. S42, well, the size of this set would be 280 divided by 42, which is 6. Then I would have an S70, that's 4, and finally S105, which is 280 divided, so that one would be a 2. So we add back those numbers, 6 plus 4 plus 2. Finally, the divisible by all 4 of these numbers, 2 times 3 is 6, times 5, 30, times 7, 210. There's only 1. So when you add and subtract and add and subtract all these numbers, you get 216. This is the number of elements in this set S which are divisible by either 2, 3, 5, or 7, or a combination of these numbers. So that solves the problem. Hope this was helpful for answering 1991 IMO problem number 3.